Transformations of f of x equals e to the x. This is the natural exponential function e to the x is. E is actually a number, just like pi is. It's used to represent 2.71828, and it continues on. It's a non-ending, non-repeating number. It's a rational number that's being represented by e. And so let's just talk about the basic features of e to the x. So, thinking about the basic features of an exponential function, the y-intercept, if there's no transformations, is 0, 1. The domain, if there are no transformations, is negative infinity to positive infinity. The range is based upon the asymptote. Well, if there is no transformations on any exponential function, the asymptote is going to be at y equals 0, and therefore our range is going to start at 0, we need a parenthesis there, and go up to positive infinity. So those features are the same as we had from the 7.2 lesson for the transformations of just exponential functions. Just these are all going to have this base of e. So we're going to look at the parent function as being that e to the x, like we had some of the functions being 2 to the x last time, or 4 to the x, or 1/2 to the x. So we're looking at that function, and we're looking at the transformation that's going to happen if I take and multiply it. So if I have that a in front of that e to the x, what does that a cause? It's either going to be a stretch or compression. And this is a vertical stretch or compression. And since it's a half, it's going to be a compression. So that means we're going to see our graph shrink down a little bit like this. And so our asymptote was not moved. We did not move it vertically. So there is no change to our asymptote. Our asymptote is going to be at y equals 0. Our y-intercept will change. And remember, you can either plug in a 0 in for the x, and so you'd have 0.5 times e to the 0 power, and find that number. Or use your Desmos or any other graphing calculator and trace and find out what's happening at the y-axis. Domain, for all of the exponential functions, it's going to be from negative infinity to positive infinity. Range, we have to go back to our asymptote, and we're going up, and so it goes from 0 to positive infinity. Now, if this had instead been a negative 1/2 times e to the x, that graph would have been reflected, and it would have gone down like this. So the negative is going to change the way the graph's shape is, as in either opening up or down, and that's going to change the way your range is going to be. So let's look at this next one. We have a +2. So that means this is a vertical shift. It is not in the exponent spot. So thinking back to our exponential, when it wasn't in the exponent spot, it was a vertical shift of 2. And so that's going to change our y-intercept. It's going to change our range, and it's going to change our asymptote from the standard. So our new asymptote is going to be shifted up 2, so that'll be y equals 2. Our y-intercept is going to shift up 2, so it'll be y equal, or 0, 3. And again, another way to find that is do e to the 0 plus 2, and that equals 3. Domain is going to be consistent. It does not change any of these exponential. My range, I look at where my asymptote starts, and that's going to be my starting value. I'm going up to positive infinity. This time, my transformation is happening in the exponent, so that means it's a horizontal shift of the opposite of whatever is up there. So that's not going to change my asymptote. It will change my y-intercept. It won't change my domain, and it won't change my range. So let's look at it. We moved the graph back to the left 5 units. So my asymptote is still has not changed. It's y equals 0. My y-intercept is off the graph here. So I'm going to go ahead and just type it in my calculator and go 0 plus 5 is the exponent. And when I do that, I get 148.413. And so I will need to read how it wants me to give me the y-intercept. And in our case, I'm going to tell you to round to the nearest 10th. So that 1 tells the 4 to stay alone. And so we have 0, 148.4. We said the domain was not going to change. And our range was not going to change because we had not moved off of the standard asymptote. So that's for the transformations. We're going to do one more where it's compounded continuously. And so let's suppose you won a contest starting in fifth grade. You deposited won a contest at the start of 5th grade. You deposited $3,000 in your account, and you get 5% annual interest that's compounded continuously. How much will you have when you enter high school 4 years later? Round to the nearest dollar. And so these equations, we are going to have a new equation. I call this my PERT equation. Principal times the amount you have will be your principal times E raised to the rate times time. This needs to be in decimal form. And so 5% changed to a decimal is 5/100. So I am going to type in 3,000 times E, which you'll find in your exponentials, times my rate, times the time, which was 4 years. Now, if you have just your phone calculator on this, you can turn your calculator sideways. E is one of the features that will show up. And so you can just even use your phone calculator to help find this number. And so this number is $3,664.21. But it wants me to round it to the nearest dollar. So that means this 2 is going to tell the 4 to stay the same. So this will be approximated to $3,664. You'll be doing one in a second where you're doing it at the entering of your senior year, which is 4 years after that. At the end of in 4 years more, so you'll be looking at 8-year time period.